I want you to take a look at this pattern. Can you tell me what's going to come next? How would you describe the pattern that the blocks make? Well, if we look at the number of blocks in each figure, the first has 1, the second has 4, the third has 9. So these are square numbers. That means the fourth must have 4 squared blocks, or 16. So to describe the amount of blocks in each figure, we could say that the pattern is n squared, where n tells us where the position of the figure is. Because in the first it was 1, and then 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, and so on. Now this is what we call a quadratic term. It comes from the word quad, meaning square. Any expression whose highest term is squared, or a power of 2, is a quadratic expression. For example, x squared plus 2x minus 3 is a quadratic expression because the highest power of the variable in this term is 2. Whereas x cubed minus 2x squared plus 2x minus 3 would not be, because the highest power of the variable in this term is 3. Would you say that 3x squared minus 1 is a quadratic expression? Yes, because the highest power in this expression is squared. How about 2x plus 1 plus c? No, we couldn't, because the variable x is not being squared. The general form of any quadratic expression is this: ax squared plus bx plus c, where a and b just represent coefficients, that is, numbers used to multiply the variable, and c is a constant. Every quadratic expression will look like this. Now, where did quadratic equations come from anyway? They've always been around in math, but the Babylonians were the first on record to solve quadratic equations. But they didn't treat it like we do. They didn't even use equations. They viewed quadratic figures as the area of squares with sides having an unknown length. For example, instead of saying 2x squared to describe a squared term, they used 2 squares. Nothing is wrong with that, because there are many different ways to represent a quadratic. We could also draw it as a geometric pattern, like the one we started out with. Or we could put it on graphs to show the path a ball travels when you throw it up in the air. So in this topic, we're going to look at 3 ways that we can solve quadratic equations. First, let's look at factorization.